Cognitive dysfunction, so problems with memory, concentration and attention, are a significant problem in the autoimmune disease lupus. Nearly 1 in 1,000 people in the UK are affected by lupus, and up to 90% of these have reported cognitive dysfunction in lupus. It significantly affects quality of life, however the cause is unclear and therefore treatment still remains elusive. My name is Dr. Michelle Barraclough, a researcher at the University of Manchester and the NIHR Manchester Biomedical Research Centre. In our paper, we hope to further understanding of cognitive function. We conducted an observational study using stable lupus patients and healthy volunteers. Stable lupus patients were defined as people who were not having a change in their treatment and scored 4 or less on the SLEDAI, a common measure used to look at disease activity. 66 people completed the study in Manchester in England within 3 years. We used 2 key methods to measure cognitive function. The first was CANTAB. This is a cognitive battery of computerised tests that measure performance looking at attention, concentration and memory. The second was fMRI, which is an indirect measure of brain activation. It allows us to look at how the brain responds to certain tasks while patients are performing certain tasks such as working memory and emotional processing that we used in our study. Given that cognitive function is really complex, we also collected data looking at psychological, demographic and clinical variables. Our results showed that the 2 participant groups were well matched on key demographics such as age and gender. We did find expected differences in inflammatory markers, fatigue and depression scores. When we looked at the cognitive function, we found that actually the lupus patients performed fairly similarly to the healthy controls on the CANTAB measures, except for a measure of sustained attention and emotional processing. What we found that was really interesting though was from the fMRI results. We found that lupus patients employed compensatory brain mechanisms to maintain this same level of cognitive performance. They used regions not usually associated with cognitive function, but usually involved in self-reflection. Now, this would affect their cognitive function in 2 ways. 1, it's more likely to make them more cognitively fatigued, and 2, it would allow emotional processing to interfere with their cognitive function. We also did some exploratory correlations, and we found that depression, fatigue, disease damage and inflammatory markers were all associated with altered brain mechanisms. So what we found really was that the lupus patients performed similarly to healthy controls on cognitive tasks, but that they had altered brain mechanisms. Essentially, their brains are having to work that bit harder to maintain the same level of performance. We did find that they do have cognitive problems at times, and this is most likely due to cognitive fatigue when we see the overt problems. The study wasn't designed to determine cause of cognitive dysfunction in lupus, but it has highlighted that there are multiple factors involved in cognitive dysfunction in lupus, and therefore when thinking about treatment you need to look at the whole profile of the lupus patient to find the correct treatment. This study has provided some great foundation for future work and hopefully a clinical trial looking at cognitive function in lupus. I would like to thank the participants, the study funders, Sanofi Genzyme and the NIHR Manchester BRC, the research team and you for your interest in this study. To find out more, go to the Annals of the Rheumatic Diseases and see our paper titled Altered Cognitive Function in Systemic Lupus Erythematosus and Associations with Inflammation and Functional and Structural Brain Changes, published on the 12th of April 2019. Thank you.